What I wanted to impress was the fact that it's not necessarily a straight path. You might try a whole bunch of different things and end up here. So how I'm going to do my talk is I'm going to start out telling you how I got into this field, how I ended up specializing in soil science. I'm going to talk about my honors project in metal contamination of urban soils, and then I'm going to end up with some tips for you guys. Okay, so who am I? I graduated in 2012. I got my bachelor's in environmental sciences. I really liked chemistry, so I did a focus in that. And then I took a couple months off. I traveled in Southeast Asia for a bit. And then I started again, more school. I did my master's starting in 2013, and I'm about to defend in about 2 weeks. And then after that, I really want to take some time off, do some professional consulting and work for industry, because I have a lot of research experience, but I haven't really worked in industry. So my story begins in Bali. I was born there. I don't know if many of you guys know where it is. It's in Indonesia, known for our beautiful beaches. When I was 7, I moved to Vancouver. Something closer to that. I wasn't really an outdoorsy kid. I was very much a city girl. But I've also always done really well at school, always really motivated. When I was in high school, what I realized was I really loved chemistry. I liked learning about reactions. I loved how complicated it was, how there was math involved, how you got to work in a lab. A lot of that was really exciting to me. And I got to learn a lot about how the world worked through chemistry. So when I started university, I really knew that I wanted to go into sciences. And then once I got into first year, what it really affirmed was I didn't want to take the life science route. I wasn't really interested in medicine and any of that stuff. What I did know was while I wanted to work in chemistry, I wanted it to have a real practical application. I wanted it to have societal importance. And the other thing I know was that I didn't want to just work with scientists. I wanted to be able to work with economists, ecologists, sociologists, policymakers. So environmental science is a great niche for that. So in second year, I applied for the environmental science program, and I got in. And right away, because it wasn't a field that I was very much familiar with, that I was really challenged by, I decided to join the co-op program, and I got in. So my first co-op, I worked at FP Innovations. It's a pulp and paper research facility. I was a lowly fiber length analyzer. I did a lot of work in the lab, sampled looking for fiber length of different species, black spruce and balsam fir, looking at what age groups would produce the best fiber length in order to make the highest quality of paper. So while it sounds like a lot of grunt work, I got connected to a lot of industry specialists, and I learned a lot about the field. After that, I was sent over to Deep River, Ontario. So that's this tiny town, 4,500 people, 200 kilometers north of Ottawa. I worked for a research facility. It was actually Nuclear Energy, Atomic Energy of Canada Limited. And they did a partner project with the Deep River Science Academy. So a lot of the kids in that program are like you guys, very keen, wanted to learn more about the field, and so I got to work on a research project with them. It was really exciting getting to mentor the kids and working with other people in the lab and getting to teach them new skills. So we worked on an ATP bioluminescence assay to test groundwater, so looking at microbial populations in groundwater. Afterwards, I ended up at UBC Forestry. So this was really my first experience working with soils. I got to work with a lot of PhD candidates, so doing field work, and that placed me in Prince George, Vancouver Island, testing for soil, for gas, for vegetation. I did a lot of work in the labs looking at microbial populations of harvested sites, and it was really the first time that I got to see what research looked like. Then my last stint, I worked for Fisheries and Oceans Canada on Vancouver Island. So again, this was something super different. I worked on chum salmon fish scales, doing microscopy, looking at the growth increments between the scales to see if there was evidence of density-dependent growth. So really, you guys might look at that experience and go like, there is no common thread between any of that. That's kind of all over the place. What I really learned from it was two main things. I really liked working in the lab. I loved working outside. I loved data analysis. I loved writing reports. So really, the diversity of work was really important to me. And secondly, what that confirmed was the fact that I really liked research. I liked working with specialists. I liked investigating things and knowing the answers to things. So in second year university, I had to take a soils course. It was kind of a required thing for my program, and I had to take it, so I took it, and I realized that I really loved it. And really the reason was that it focused, there are so many different things you can investigate. If you like physics, biology, chemistry, there's a niche for you. It's really dynamic, so it's challenging because you have to think on an ecosystem scale. And lastly, there's a lot of importance to our society. We're always going to need, we're always going to need to eat, we're always going to have to build buildings, and we're always going to have to need ecological services from our soil, purification of water, nutrient cycling, etc. So this is our soil kedon. You have the typical soil. I don't know if you guys know anything about it. Your top layer, your A horizon, very rich in organic material. Your bottom horizon, just below that, the B horizon, a little bit lighter, less organic matter, more clays. And then your C horizon is your untouched parent material. That's your rock material. There's 5 factors that determine your soil that can make it up, which is your climate, organisms, relief, parent material, and time. Now your soil is an open system. There's tons of things happening. You have things being added, things being lost, things being transformed chemically, biologically, physically, and then moving up and down the profile and really altering the properties of the soil. So more familiar, you guys might be more familiar with this, is an urban soil. So these are soils where, that's actually the EBC farm. A lot of things we've actually altered through human activity, through anthropogenic influences. So we've added stuff, chemicals, fertilizers, pesticides, construction fill, really gross stuff. We've mixed it, we've compacted it because we do a lot of activity on these soils. And then there's a lot of industrial activity because you're not just leaving those sites alone, you're doing stuff on it. And what that really does is you change the plant growing zone. It's not this like natural, beautiful, rich organic material anymore. There's a lot more stuff in it. So I knew that when I was going to pick my honors research, I wanted to do something related to soils because it was something that I was starting to grow really interested in. But I knew that I also had about like 4 years of research in environmental contamination. So I wanted to combine those 2 things together. And what I wanted, and really the combination of those 2 things is metals, right? Do you guys know a lot about metals? Anybody know about contamination of metals? Something that's relatively common in our cities, okay? So we know that there's tons of research about this. The fact that if you dig a pit in the city, you're going to find metals, and oftentimes you're even going to find it in your food crops. Now, community gardens in Vancouver are a growing field. It's always going to be growing. It's something that we really support. Yet the issue with them is that we tend to place them on sites that may be contaminated, are much more likely to be contaminated. So this poses the question, like, is that okay? Is it okay if we want to grow something like community gardens, that we put them on sites where there's potentially much more metals in them? So that's when I came up with the idea of my honors research, which is assessing metal contamination in urban soils in Vancouver. So we picked 3 sites that we wanted to investigate. The UBC farm, which you might be familiar with, 16 Oaks Community Garden. So the UBC farm was actually managed for about 40 years at the time, already a lot of organic material amended, put into it. The 16 Oaks Community Garden had been established for about 3 years. Before that, it was a parking lot and a restaurant. And lastly, this brownfield, so this vacant site, was actually a scrap metal yard from the 1970s until about 1980s, and then it was remediated, a lot of construction fill put into there. I investigated 5 different metals: zinc, lead, copper, nickel, and manganese. And then we looked at several different things. So the surface material, the soils, did different kinds of chemical extractions to figure out what the concentrations of metals were. Looked at the root and the shoot of this grass that was growing on all 3 sites. And then looked at wet and dry deposition. So deposition is metals coming in from the air, either through rain or through wind currents. So wind would be the dry deposition and rain is the wet deposition. And then lastly, we looked at official and anecdotal information. So really, we wanted to know what the site histories were of those 3 sites. What did we find? So this is a graph of the concentrations of metals in the native soil or surface material. So you can see, surprisingly, concentrations were actually highest in the 16 Oaks Community Garden, secondly in the brownfield, and lastly in the UBC farm. The high concentrations were found for zinc, followed by manganese, and then lead, copper, and nickel. Now when we look at what's coming in through the air, most of it is coming in actually as dry deposition. You're seeing a very familiar trend. Again, the community garden is the highest and the lowest in the farm. But in this case, we see that zinc is the main contributor. So what are the environmental contributions? What we found was that rock material, that parent material, contributes predominantly nickel and manganese. When you look at the industrial activity, so the human influence, what that's putting into the system is mainly your zinc, lead, and copper. You find that those concentrations are much higher in the industrial sites compared to the farm. And some of them are even higher higher than provincial standards, so that might be a concern if we want to grow food on there. We found that for stuff coming in through the air, they're mainly deposited dry, and you can get meaningful contributions of zinc, lead, and copper in the urban environment. And lastly, we saw bioaccumulation of metals in the root and shoot of koa. What does that mean? That means that when we measure root and shoot, the metal concentrations in them are much higher than what you're seeing in the soil. So to end, the conclusion for that study wasn't don't plant, don't grow stuff in community gardens, but it's really that we need to be careful and to think critically about where we're going to site our community gardens. We need to think about the natural contribution of metals, okay? So that parent material has a big influence on what you're going to find in your soils. We need to think about the site history, if that site has been contaminated in the past and what's there right now. And then we have to think about the fact that there is pollution entering that system currently. And if you're going to be on that site for 5, 10, 15 years, even though the metals may be a little bit at a time, after 20 years it can be significant. Okay, so the take-home message for you guys really is don't limit your learning. You don't really know where you're going to end up. Okay, so don't be scared to try things. Don't be scared to try a variety of courses, a variety of work, volunteer experiences, even if you don't necessarily see the end point right when you're doing it, or you can necessarily say you're completely interested at that moment in time. And lastly, always stay motivated, engaged, and inquisitive. Don't reach a point where you feel too comfortable where you're at. Challenge yourself, okay? Talk to your peers, talk to your professors, get engaged, and be really interested in what you're doing. Don't settle for less.